Hey guys, this is Mr. C, and in this video I'm going to show you how to solve some linear equations. So I'm going to start it out easy with a little two-step equation here. So when you have a two-step equation, and hopefully you've mastered one-step equations, when you have a two-step equation, you have a constant, you have a coefficient of x over here, and then you have a constant on the other side usually. So in this little two-step equation, you always want to deal with the constant first. And so what you do is you move that number, whatever it is, to the other side by using the opposite operation. And what happens is these two guys here are additive inverses and they make 0, and so that's why it goes away. But you're going to change the other side. So that's going to form the basis of most of my other problems coming up here. The 2x, we didn't do anything to it. So what happens is the 2x just kind of drops down, and that's equal to whatever this turns out to be. So 13 plus 5 is 18. And then if you did that correctly, you're going to have a one-step equation right here. In the one-step equation, in this case, you just divide by 2 on both sides, whatever the coefficient was. Those are multiplicative inverses, so they go away. And then x equals whatever this turns out to be. And it turns out that 18 divided by 2 is actually 9. And so we have an integer answer for that. But you can get fractions. So if you do get a fraction, just remember it's okay. A lot of times you will get fractions as your solutions. In this one, we've got a little distributing going on. It's still variables on one side, but it's not two-step anymore. It's a multi-step. And so the first thing you're going to want to do is distribute this 3 to both those guys in the parentheses. When you distribute with multiplication, you're going to get 3 times x, which is 3x. And then 3 times 4 is 12. There is a plus there. So plus 12, and hopefully we know that addition and plus is the same thing as positive, equals the 15 on the other side. Now we have a two-step equation. We're going to subtract 12 on both sides. And some teachers might also do this because students sometimes will do things to one side or the other and they're not supposed to. And some teachers will say, you draw this river right there, and what you do to one side of the river, you have to do to the other side. And so the two 12s cancel. Again, you're going to bring down this 3x because you didn't do anything to that, equals 15 take away 12 is 3. And now we have a one step. Divide by 3 on both sides. Those 3's cancel, and x is equal to 1 because 3 divided by 3 is 1. So those two 3's cancel because they're multiplicative inverses. So there's always a reason, mathematical reason, for what you're doing, and there's a name for it. And sometimes those are even on end of course tests, just knowing the property that you used. So I'll be mentioning the properties as we go too. Okay, in this example, I've got a fraction here. And so I know how much people love fractions, which is not at all. Don't worry, I don't really like them either because they tend to make my day a little more difficult. So I'm gonna try to make your life a little easier. So when you distribute this 3/4, the last thing I'm gonna do is use a calculator. Most of the time, these two numbers are going to be multiples of that denominator. And what happens is when you take 3/4 times 4, 4 times 3 is 12, divided by 4 is 3. And so all of this right here just becomes 3x. And you could also just divide the 4's out. Now, I don't like doing that because if I divide that 4 out, then I kind of cross through it, and I need to use that again for the 12. All right, so let's go over here. 12 times 3 is 36, right? Divided by 4, and that would be 9. There is a minus there, so we need to write minus 9 right here, equals 21. All right, so now we have a two-step equation. Add the 9. 9's cancel, additive inverses, bring down my 3x. 21 plus 9 is 30. And now just divide by 3, the coefficient, get rid of that, and x is equal to 10. And what you should probably do is, when you're doing these, especially on tests and the EOC and whatnot, you should take that number, that solution, and plug it back in just to make sure that it does work. All right? And then when you have more time, you can definitely do that on your own time. Okay, this one, we've got a couple parentheses on the left side. And so since there's just a 1 here, there's just a 1 there, and they are added, I am allowed to take the parentheses away and just write 2x plus 9 plus 3x minus 1 equals 143. So where you're going to see this kind of a problem is in geometry when you have a total angle value in degrees and you have two separate ones, the angles being split up into two other angles, and you have to find the value of x and then the value of each angle. And so this type of a linear equation is seen in geometry quite a bit. So now we need to take this left-hand side here and combine some like terms. So I have a 2x and a 3x, and that makes a 5x. We have a positive 9 and a negative 1, or a minus 1. That's going to make 8. And that's equal to 143. So now I have a two-step equation. So now I need to go ahead and subtract 8 on both sides. Those cancel. Bring down my 5x. And now 143 take away 8 should be 135. Okay, so now I'm at a one-step equation. I divide by 5 now, and x is equal to whatever that turns out to be, and that should be 27, I believe. And then you're done. And again, you can plug the 27 in here and make sure that this side gives you 143 by just evaluating this side, and you should get 143 when you plug that back in. All right, let's take a look at this one. All right, so this one has a minus in the middle and it's got a 7 and a 2. This may not come from geometry. It might, you never know. You can get them somehow. But here for this one, I need to distribute the 7 first. So let's do that. 7x minus 7 times 4 is 28. Okay, so now we need to do this. And I need to, when I distribute it, remember that that's a negative 2 right there. So negative 2 times 4x would be negative 8x. And hopefully by now we know that negatives and subtraction basically mean the same thing. Negative 2 times negative 1 is going to be a positive 2. And that's going to be equal to 30. And now we can clean up our left-hand side here. I've got a 7x and a negative 8x. That would give me a negative 1x. I have a negative 28 and a positive 2. So that should drop me down to a negative 26 equals 30. Okay, I'm going to add 26 to both sides because this is still a two-step equation because of that negative right there. Those cancel. I bring down my negative x equals 56. So, but x doesn't equal 56. Negative x equals 56. So now I do need to divide by negative 1 to get rid of that negative, and now x equals negative 56. And since that's a negative number, that would be a good geometry problem because most of those x values, most of the time, will be positive when you get done solving for x. All right, so let's move on to some equations with variables on both sides. So how do we do this one? Well, in my brain, since I've done so many of these, I want to get the x's dealt with first. So I've got a 6x plus 5 and a 2x minus 7. And I'll ask students what to do first, and I'll say combine like terms. And then I'll say, well, wait a minute, that's just a 6x plus 5, and that's just a 2x minus 7. So you can't really combine like terms at all. You need to start moving stuff around. And I want to go ahead and move the 2x over. That's just a habit that I have. Because now 6 take away 2 is 4x, and I've made it positive. I don't really care if the x winds up on this side or this side. That doesn't bother me, as long as I get a positive result. So, but that's just the way I do it. You still have a plus 5 over here, and you still have a minus 7 over there. So now, let's subtract 5 on both sides. So those cancel. I'm going to bring down my 4x equals negative 7 take away 5 is negative 12. Okay, divide by 4. And it looks like x is going to be equal to negative 3. And that's about the speed that you should be able to solve these kind of simple equations that have variables on both sides. Because there really wasn't any distributing or anything like that I had to do, or fractions or anything. Okay, so here's another one. Now my thing is I want to move the x's around first, but you don't have to. You could subtract 5 on both sides. You could add 2 to both sides. You could subtract 2x. You could subtract 8x on both sides, or you could add 15 to both sides. So you have 4 things you can do. I'm going to go ahead and add 2x to both sides, and my students usually kind of start to have the same habit that I have. They cancel there. I bring my 5 down, and I don't really care that my x's are now over here. It doesn't bother me. 8 plus 2 is 10, and then still minus 15 because I didn't do anything with the 15. Now I have to move the negative 15 to this side because I'm trying to get x by itself. So I'm going to add 15 to both sides. There they cancel. 15 and 5 make 20 is equal to 10x. And now you're going to obviously be able to know what the answer is. Divide by 10. And then 20 divided by 10 is 2. Okay, so that's my correct answer. If you wrote it like this, is that also correct? And the answer is yes, because an equal sign is equality, which means you can flip these around however you want, and it's still the same equation. 2 equals x, x equals 2, same thing. It's no big deal. In the back of a textbook, that would probably be the answer they would print because they're more than likely going to put the x on the left side, even though it's not required to do that. All right, let's take a look at this one. Variables on both sides, but we have to distribute first. So we're going to do that first. Okay, negative 4 times 2x is negative 8x. And I have to be careful so I don't go too fast. Otherwise, I'm going to make a mistake. Negative 4 times 1 is minus 4 equals x plus 14. Nothing happened over here. Okay, now I'm right back to some of the other problems I've had. I'm going to add 8x to both sides. Just what I want to do. Those cancel. I bring down my negative 4 equals 8 and 1 make 9 plus 14. Okay, I'm going to go ahead now and subtract 14 on both sides. Like that. That cancels. And now I've got negative 18 is equal to 9x. I'm going to divide by 9. And it turns out that negative 18 divided by 9 should be negative 2. And negative 2 is equal to x. Let's check that. Well, we can check that real quick. If we plug in a negative 2 here, we're going to get negative 4 plus 1 is negative 3. And negative 3 times negative 4 is positive 12. If we plug in a negative 2 here, negative 2 plus 14 is also 12. And so when we plug that negative 2 back in our solution, then we get 12 on both sides, so we know we're correct. All right, let's try this one. This is the dreaded fractions, and so how do you handle fractions? Fractions really aren't that big of a deal. Let me show you how to handle these. We're going to use a technique called clearing out fractions. And when you clear out fractions, what you want to do is get your common denominator, least common denominator is better, of all of the fractions in the problem. So you got 2, 3, 2, and 6. The least common multiple of 2, 3, 2, and 6 is 12. Well, I'm sorry, 6. So you could use 12, but 2 goes into 6, 3 goes into 6, 2 goes into 6, and 6 goes into 6. So let's just use 6. Okay, so I'm going to multiply everything up here by 6. And that's how I would do it on the board. All right, so let's see what happens. 6 times 1 is 6, divided by 2 is 3. So this whole term is going to turn out to be just 3x. 6 times 5 is 30, divided by 3 is 10. So this whole term becomes 10. 6 times 2 is 18, divided by 2 is 9. So this term becomes 9x. And then 6 times 5 is 30, divided by 6 is 5. So that's minus 5. And now we're right back to the problems with variables on both sides, the easy ones. So I'm going to subtract 3x on both sides. Drop my 10 down. 9 take away 3 is 6. Minus 5. Add 5 to both sides. And I get 15 is equal to 6x. If I divide by 6, now I can take 15 and 6 and I can actually reduce that fraction down. 3 goes into both of these, and so that would actually be 5 halves. And so 5 over 2 is equal to x. That's the answer that we want. And students may look at that and go, well, I did something wrong. And I'll say, why? Well, because I got a fraction. Fractions are legal. You can get fractions as your answers. You get them all the time. So if you get a fraction as your answer, I mean, don't think that you naturally just did something wrong. It could very well be a fraction of 5 halves. And I'm not going to write that as 2.5 either. I'm just going to leave it as 5 halves and just be done with it. So that's how I handle some fractions. And let's look at this last one. And let's get a different marker here. This one looks good. All right, so we got some simplifying to do. First thing we need to do is distribute this negative right there. So we got 4x minus 3x, and then a minus and a plus. When they fight it out, the minus wins. So minus 8 equals, and now we have to distribute this side. So we're going to get 2x. 2 times negative 3, or minus 3 is negative 6, minus 6, and minus x. All right, now we can clean up both sides. 4x take away 3x is 1x, minus 8, equals, and now over here you have a 2x and a negative x. Well, a 2x and a negative 1x are going to leave 1x minus 6. I've seen this one a lot on the ACT problems. So here's what happens now. I'm looking at this, I'm thinking, I got an x on both sides. That's kind of weird. If I subtract x from both sides, they both cancel out, they're gone. And I have negative 8 is equal to negative 6. All right, is that a true statement? No, that's a false statement. Since that's a false statement, the answer would be no solution. Or you could write it as the empty set, because no matter what value for x you plug in here, none of them are going to work at all. It can't be solved. The converse of this, if this was a true statement, like negative 8 equals negative 8, then it would be all real numbers. Any number for x would work. We call that an identity. And so this one is a contradiction because it has no solution, and then that's all you can do. The last thing you want to do here is cancel your x's out and still have an x sitting right here in this. Once you cancel those x's out, they are both gone, and now you're left with a false statement and it's no solution. All right, guys, hope this helps for your solving some linear equations. Remember to like and share and subscribe to my channel, and we'll see you guys later. Bye.